Let's do this thing.
This is too hard, miss. Okay. So we're going to start with some triangles here. And if you recall, back in the dark ages of your youth, you probably learned some of the different names for triangles and how they can be categorized. And you can categorize triangles two ways. You can focus on how big their sides are, or you can focus on their angles. And this is something you do with humans too. We categorize people, and you can categorize people in more than one way. So those at home get to just listen to us do this. So first we're going to categorize you by your eyeballs. So first check that you have eyeballs. Okay, yeah, all right, they exist. Now, I need you to stand up if you have brown eyeballs. Okay, so people stood up. Now take note of who is standing and who is sitting, and see that not everybody fit into the brown-eyed category. There are other categories. Shh. What other categories do we have? Blue.
Brandon.
Green.
Green, or some of them have green. Hazel is a thing. I have a kid with hazel. Okay, cool. Sit down. Now, I'm going to classify you by your ears.
Oh, mine are attached.
No. Stand up if you have pierced ears. Okay, so, you have a pierced, okay. So, are some of the people who were standing up before sitting down now?
Yes.
Yeah, a lot of them. Are some of the people who were sitting down before now standing up?
Yes.
Is there anybody who stood up the first time and the second time?
Yes.
Yes, so, thank you, y'all can sit down. The same thing happens with triangles. I'm going to ask you to classify them, and you can classify them in more than one way, and you have to pay attention to what I ask you to classify them by. If I ask you to classify triangles by their sides, you're going to be focusing on how big their sides are, and don't worry about their angles right then. Okay? So, we have names for the different categories of triangles. The first one is scalene. And rather than give you a definition and an implied statement, I'm just going to jump straight to your implied statement that you get to memorize. And so we're going to tell you that a scalene triangle, now I'm lazy, so instead of writing the word triangle, I'm just going to draw a cute little triangle. Do yourself a favor though. If you draw a little triangle, don't let it look like your angle symbol. Because sometimes people get kind of lazy with their symbols and they all kind of look the same. And that was okay before, but now you don't want your angle symbol to look like a triangle because we're going to use them both in the same problems. So make sure everything's readable, please. And so a scalene triangle is going to imply some stuff. The first thing it implies is that you have a triangle. I know, shocking, right? And it's a triangle with no congruent sides. Whoa. So now I want you to draw yourself a sample picture of a scalene triangle. Try and draw one that's scalene. Sure. How can you make for sure that it's scalene? You have to show that all three sides are different lengths. So maybe you mark this one with 1 mark, and this one with 2, and that one with 3. That would prove it's scalene. Or I might tell you all 3 lengths, and you'd know that 27 and 17 and 10 are not all the same length, or something like that. Okay? So that's scalene triangle. You scared yet? That's one implied statement. Let's do some more. Oh, I will give candy to the person who thinks they can give me the implied statement exactly for an isosceles triangle. Nobody's done it yet. Go ahead.
I want to try.
Give it a shot.
Isosceles triangle.
Okay, is it okay if I'm lazy and just put isos? Yeah, so isosceles triangle implies
A triangle with... Oh, I thought it was with all equal, all congruent sides, but it's not.
it's not. Oof, so you don't get it. Nikita? Oh, so close. You've got part of it.
With at least.
What's that?
With at least.
At at least 2 congruent sides. Now, that's different than what you were taught back when you were little younglings in your childhood. You were taught that they had exactly 2 congruent sides. But that's not the whole story. Something that's got more than 2 is technically isosceles. Well, what's the only amount you can have more than 2? 3. A 3 congruent sided shape still has 2 congruent sides in it, doesn't it? And then it has a spare congruent side. So it is technically isosceles even if it has 3 congruent sides. It's just like isosceles plus plus. Okay? It's extra. And so, okay, you decide to draw a cute little picture of it. How do you make sure that you know it's isosceles? Mark 2 of the sides being congruent. If the third side happens to be congruent, well, cool. But this is all you need to be sure you're isosceles, because that's at least 2 congruent sides. Okay? So now you're all scared. It's like, what other things did my teachers not tell me back in the past? Oh, you've been lied to so much. So much. Equilateral. Anybody want to try for the candy for equilateral implied statement? Okay, oh wait, wrong thing here. Arf?
Equilateral triangle.
Okay, hold on. Could I abbreviate to equa? No. Guess why? You need the L to tell me it's equilateral. Because later on, we're going to have a little thing called equiangular. So you need the L to let me know that you're doing the lateral part, okay? So at least do that much. So equilateral triangle implies, okay, who's doing this one? You're still going.
Triangle with all 3 sides congruent.
With 3 congruent sides. Okay, go get it. You did good. That one's not so tricky.
What?
Okay? All right, draw one and mark it so that nobody can be mistaken that it's anything but an equilateral triangle. And my guess is you draw a shape that looks something like the classic triangle of your childhood. But now you've marked it to prove that, yes, for sure, this one has to be equilateral because it's got 3 congruent sides. What else is it? It's also isosceles. So equilaterals are like the special isosceles. They're the isosceles with the extra thing, so they also get to be called equilateral. Just like y'all are all students at the Woodlands High School, but you're also honors geometry students, because you're extra. You're in here suffering all year. Okay? So that's 3 implied statements down. Shall we do some more? Too bad, we're going to do them anyway. All right. Do I have a volunteer for acute triangle? Okay, Jackson, go for it.
Okay, so an acute triangle.
Hold on, acute triangle implies, and you notice these are all biconditional?
Yeah.
You did catch that, right? So what's an acute triangle?
A triangle
It is a triangle.
with all angles less than 90 degrees.
Okay, but let's use the word that's in the implied statement. So you're close, but that's not quite what we write down. Just like when we say linear pair, do we say it's angles that add to 180? No, we say it implies supplementary. So an acute angle implies a triangle with?
Measured,
Yes.
all measured angles less than 90
No, you're thinking too far ahead. See, you're too smart, and you're making a logical leap that we can't make yet. Baby steps. How many? 3. With 3 acute angles. The reason why you have to specify 3 is that every triangle in our geometry has 2 acute angles. They always have 2. It's that third angle that tells you your classification by angles. So if the third one is acute and all three are acute, then yeah, you've got an acute triangle. Well, what if two of them are acute, but then you've got something else? Well, then you have to pay attention to the something else. So, victim, please, for what you think a right triangle is. Oh, more and more people. Graham?
A right triangle implies a triangle with one right angle.
With one right angle. Okay. Ooh, goody. Thank you.
So what the frick, man?
Graham.
They're ganging up on me.
All right, this is not for now. This is for later. Okay. So you have one right angle, then what are the other two angles going to be? Acute. Remember, triangles always have two that are acute. So yeah, one of them's right, the other two better be acute. And so if you want to draw yourself a picture of a right triangle, how do you make sure you know that it's a right triangle and not an acute triangle? Put the little right angle box in it. And so, a right angle implies, the right triangle implies that you have a right angle, and then, as he was trying to skip ahead to, then you can say that the right angle implies that it measures 90 degrees. Okay? Isn't it hard taking that big brain of yours and pulling it back and not letting it jump so far? It can be tough. But, you'll learn, don't worry. Victim for obtuse triangle. No? Is that a hand up? Okay, go for it.
Obtuse triangle.
Obtuse triangle implies.
A triangle with one obtuse angle.
Beautiful. Get your candy. Now, the only way you'll know a triangle has an obtuse angle is if I either tell you the angle amount and it's bigger than 90, or if I tell you it's obtuse. You cannot assume. So if you see something that's like this, and you're like, well, that kind of looks obtuse, don't trust it unless I tell you. Okay? And so if you know, oh yeah, that's an obtuse angle, well then you can believe it. But we try not to trust the pictures because sometimes I'm a bad artist. And sometimes we're just deceiving you.
Bro, what the frick?
Okay? Wait a minute, hold on. Obtuse triangle. One angle is obtuse. What are the other ones? Always acute. If you already know one of them, you know the other two have to be acute no matter what. Two of them are going to be acute. It's that third one that tells you what you get to be. Okay. Do I have a volunteer for equiangular? A few people. Okay, go for it. Rick. Okay, now there's a couple ways you can write equiangular and be lazy. You could put equa and put an A there for angle, but I get lazy and just put the angle symbol for equiangular. And it doesn't matter which one you do. So you could do equa with an A or equa with an angle. It's the same thing to me. But then if you put the triangle symbol next to it, you better make sure you can tell the triangle symbol apart from your angle symbol. Equiangular triangle. Implies something. So, what are you going to give me?
A triangle.
No, were you the one I asked?
Yeah.
Okay.
A triangle, all equal angles.
Triangle with what?
All equal angles.
Oh, and see, this is where your teachers deceived you. They told you that if it says equiangular, it means equal angles, but guess what?
With 30-figure angles.
They're congruent angles. And so the word itself is trying to fool you here, which is so rude for all my people who are trying to learn like 3 languages at once. And then I throw in garbage like this that sounds like equal, but then you have to make it congruent. So unfair. Did you get your candy? Okay. Okay. So it's 1, 2, 3, 4, 5, 6, 7. Oh, that's uneven. That's uneven. We need to fill in this gap over here. So let's see. What could I imply? I've got something. This equilateral triangle, it's got something else it implies. two candies, whoever knows what else it implies. Yes, sir.
It's an equal angle.
Very good. It's equiangular. Equiangular. If you have all three congruent sides, because equilateral is three congruent sides,
Yeah.
then you'll have three congruent angles altogether. I know, your mind is blown. It's amazing. So I have a question for you. Oh wait, no, I'm going to save it. I'm going to save it for later. Let's do some more words. You need to learn more words. Interior angles. Anybody have a guess? This isn't an implied statement. This is just what are they? What an interior angle is. Yes, sir.
Angles on the inside of the triangle.
Angles inside the triangle. It's very astonishing. And so let's number them in our little picture here. Let's say, just so you know that for sure, I'll call this one angle 1, this one angle 2, and that one angle 3. Those are my three interior angles of my triangle. You okay with them? Okay. Now over here, will you please mark the same three interior angles in this picture? The interiors. So 1, 2, and 3. Now they're the interior angles. But what was I asking you in this side to focus on?
Exterior.
Because exterior angles are the difficult ones. Because there's lots of angles outside the triangle. So exterior angles are angles outside the triangle, but not every angle outside the triangle gets counted as exterior. And this is where people get mixed up. Okay? The angle outside, so angle outside the triangle must make a linear pair with an interior angle. So in this one to the right, that just has the one line sticking out of it, see how that one line coming out of the triangle forms a linear pair. Let's call, this angle what? 4. Angle 4 would be an exterior angle because it forms a linear pair with one of your inside ones. So looking over at this one that's got all these lines, see how these vertical angles to the interiors, see these guys? Are they counted as exteriors? No. Because they're not linear pairs with the interior angles, they're vertical to them, so these guys don't count. Those are not exterior angles. The only way to make an exterior angle is to take one of the sides of your triangle and extend it out, and then make the linear pairs. So like this one could be 4, it would be exterior. Is there another exterior angle connected to angle 3? Yeah, down below it. We'll call it angle 5. So angle 4 and angle 5 are exterior to angle 3. How many are exterior to angle 1? Also 2. And notice that the exteriors are vertical to each other. So each interior angle has 2 partners that are considered exterior. So what should we call these ones? 6 and 7? So angle 6 and angle 7 are exterior to angle 1. Because here's angle 1, here's angle 6 and angle 7. And then up here at angle 2, what would be exterior to angle 2? What do we call those guys? 8 and 9? Sure. I mean, you could have skipped ahead. I don't care. It's your paper. You do what you want. Okay? Now, I don't think you've learned enough words yet, or implied statements. So, let's learn a theorem. Remember, theorems are things that have been proven to be true. So this has been proven. And this one's based on the parallel postulate. This is one of the ones that, remember the parallel postulate, you had to have faith. You had to believe that you could draw only one parallel. But if you do that, then this theorem is true. Guess what it's about? Triangles and sums. What does it mean to sum? Add. So guess what we're going to add in the triangle sum theorem?
Angles.
Well, close. We want to not add angles, but add the measures of the angles. So, look, here's angle A, here's angle B, and here's angle C. I'm going to add their measures. So the measure of angle A plus the measure of angle B plus the measure of angle C. Guess what the triangle sum theorem says they add up to?
180 degrees.
180 degrees. I know. It's amazing. Eventually, because that's a triangle thing, but baby steps. Okay, so you can make an implied statement out of this. So you can say that the sum of the angle measures in a triangle implies 180 degrees. Isn't that awesome? So that's 9 implied statements. I feel like count on Sesame Street. 9 implied statements. Crash. Yes?
Is it by condition?
No. Because what if I'm in a different shape and I have or a linear pair that's 180 degrees? So it's here. If you start with the sum, I've got the 3 angles of a triangle. I know that I can get 180 degrees. Okay? Oh, look, right next door. We have a little thing called a corollary. Not a coronary, that's your heart. Corollary. You know what happens with corollaries?
Correlate.
They correlate. No, they co-relate. They follow from this guy. So from this guy, something special happens when you have what kind of triangle is this? Well, it's a right angle, which makes this a right triangle. So when you have a right triangle, okay, that's triangle. Yeah, see how important it is to write them nicely? Okay. In a right triangle, is this a right triangle?
Yes.
How big are the other 2 angles going to be? So this one's going to be acute, and this one's going to be acute, because this one's right. Okay? Well, wait a minute. If all 3 of them add up to 180, and this guy's 90, how much do these guys have to be?
90.
Well, do they have to be 45 and 45? No. But what do they have to sum to?
90.
So the acute angles sum to 90 degrees.
Complementary.
Oh, they're complementary? Oh, because angles that add up to 90 are? We can make an implied statement out of this. So let's see. We've got the acute angles of a right triangle implies complementary angles. Thank you for making that connection for us. So that's 8, 9, 10! 10 implied statements!
Is it by condition?
No, No, this one? Because not every set of complementary angles is going to imply that you are the acute angles of a right triangle. It doesn't work going backwards every time. It could, but it doesn't for sure. Okay. Shall we start seeing what kind of trouble we can get into with this?
Yeah.
Oh, absolutely. Turn it over. Oh, you want more implied statements?
Yeah.
Oh, he said yes. How about we see what kind of trouble we can cause with this first? Okay? So, what do you have in your picture?
90.
A triangle.
Right triangle.
It's a right triangle. Okay. So wait. What do I know about the acute angles?
So 90 degrees.
They're complicated.
They're complementary, and complementary implies they add to 90 degrees. So then, I could say that 2x plus x has to equal 90 degrees then? Nice. Shall we play around with that? What's 2x plus x?
3x.
I know, this is complicated stuff here. And then you can divide by 3 and get x equals 30. Well, yeah, so yay, found x. Oh, is that what it told me to find?
No.
Darn it. So how am I going to find the measure of angle J? I'm going to plug 30 in here and get what?
30.
Wow. Now don't leave it naked. X you might have left naked because it's just a number. But as soon as you say that you've got an angle, you better put that degree symbol on there. Some of you lost points on your test for that, by the way. That last page where it had the big picture where you found all the angles. Yeah. And the measure of angle L. What's the measure of angle L?
60.
It's 2 x's, which will be
60.
60 degrees. I know. Oh, you guys, you're going to get to be such good friends with this triangle. This is a special triangle called the 30, 60, 90. You're going to learn way more about this than you ever wanted to know. You're going to have memorized that 30, 60, and 90 go together. And then you're going to learn about their best buddy, the square root of 3. And it's going to be a good time. You look very excited. Yeah, I can tell. Okay? Now, remember those exterior angles we talked about?
Yes.
Find one in this picture. Point to it.
One.
One.
No, I didn't say tell me, I said point to it. There it is. So here's an exterior angle. Okay? Now, notice something. This angle is a linear pair with this guy, isn't it? So they're supplementary. But wait, don't the 3 angles of a triangle add up to 180? So these 2 are supplementary with C, and this guy is supplementary with 1. I bet I could do a proof to prove stuff about this, but I'm not going to. Instead, I'm just going to tell you that conveniently, these 2 angles out here are related to this one. You want to let them in? Get candy. So this is an exterior angle. Okay. Now these guys right here, what kind of angles are angle A and angle B?
Acute.
Do we know for sure they're acute?
Yes.
No.
We don't know. All you can see in here is that they're interior. Now, are they the interior angle that's close and buddy-buddy to angle 1? No, they're far away. And in the age of Zoom, those who work far away from their office, maybe they work at home, maybe they work somewhere else. What's it called when you work not in your office? Do you know? It's called remote work. And these faraway angles that are working far away from this exterior angle are called the remote interior angles. The close-up guy is its linear pair. But the far away ones are called remote interior because they're modern. They've upgraded to the current terminology. You know, because everybody talks about remote things nowadays instead of, you know, far away things. Okay? So, the fun part is now, is that the exterior angle is equal to the sum of the remote interior angles. So in this picture here, this has equal in it. What equation can I write now, knowing this theorem? The measure of angle 1, that's my exterior. What does it have to equal to? Measure of angle A.
Plus the measure of angle B.
Angle A plus, and what's that you said?
The measure of B.
Measure of angle B. Perfect. Oh darn, we didn't put this one as an implied statement. Aww, don't worry, all those other ones are on there. See, they're all on there.
Yay.
Yeah. I think it's brought us down to number 53 is how far we've gotten today. On the second page, we've done this whole first sheet, and now we're on the second sheet of implied statements. So let's play with it. Let's try this problem. It says find the measure of angle JKM. Find it. Oh, there it is. It's right there. Oh wait, that's the angle. It wants us to find the measure. Ah, so close and yet so far. How are you going to do it? You're going to have to look at the picture and figure out what junk do I have here that might be useful. What do I know about angle JKM? Well, it's exterior. What do I know about exterior angles? They're linear pair with this guy, but I don't know anything about this guy. What else do I know?
They're equal to the remote.
It equals the sum of these remote interior angles. So this guy out here, so my 2x minus 5 angle has to equal this x plus the 70. Convenient! Do you know how to solve it?
Yes.
I hope. Because once you set it up, you were supposed to already learn the algebra last year. So what does x come out to be? 75! Cool, is that what it asked me to find?
No.
Darn it. So now I'm going to have to come back over to angle JKM. And I know that it's going to be 2 times x minus 5. And you said x was 75?
Yes.
So the measure of angle JK, what's 2 times 75? 150. It's $1.50. Minus 5? 145. And then since this is actually an angle, guess what? It gets a degree sign. Don't leave her naked. Oh, that was me. I was just so excited. How you feeling? Shall we try another one? Now that you've survived one? Okay. Left or right?
Left.
Okay, everybody says left. So over here on the left, what do you see in the picture?
Interior.
Oh, I see an exterior angle.
Remote.
Oh, like that. Do I have both of the remote interiors?
Yes.
I can make an equation out of this. What equation?
5x minus
Yeah, the exterior guy
is equal to 3x plus 4.
plus the 40. These two guys added together. Nice. So you go, okay, I think I can do some algebra here. So I can subtract 3x from both sides. That's going to give me 2x. I'm going to add 10 to both sides, and that's going to give me 50. Uh-huh. Now what? Still got to keep going. I don't want two x's. And so x is 25. Oh, look, I did the hint. I found x first. Now what do I have to do? Which angle is it telling me to find, though? Really? Double check that.
ACB.
Where's angle ACB?
Exterior.
Really?
Interior.
It's this interior angle right there. It doesn't have any letters or numbers in it. However will I find it? What do you think?
Find the exterior angle and then set it, add it, or subtract it from 180.
Yeah, it's a linear pair with this guy. So if I can find the exterior angle next to it, I can find it. So I go, okay, so this guy is equal to 5 times 25 minus 10. That's the measure of angle ACD. And how big is that? What's 5 times 25?
150.
Then it's 125. Count your quarters, y'all. 25, 50, 75, 100, 125. Take away the 10. That's 115. Okay? So this angle is 115. But that's not the angle I wanted. So now, how do I find the measure of angle ACB?
Subtract it from 180.
Yes, since they're a linear pair, I can do 180 minus the 115, which comes out to be how much? 65? I'll believe you. And don't forget the degrees, because it's an angle. So in a lot of these problems, we're not going to give you just, here, find this guy, plug in. No, you're going to have to do some thinking. So don't get ahead of yourself and start going fast. If I tell you an angle, don't assume you know what it is. Go find it. Make sure you know what you're finding, because we will try to be tricky. That's our job.
Isn't it easier if you just plug in 25 at the other angle and then add those?
Could you have plugged the 25 up here and then used the three angles of a triangle, adding to 180 to find this guy? You could have. Is it necessarily easier? Depends on who you are. If you don't remember to do that, is that very easy? No. So, do I care which way you do it? Also no. As long as you get the right answer, other than cheating, don't cheat. As long as you get the right answer, we're good. Okay? Now, what I want you to get out now is that little half-size piece of paper that we did and picked up on the way in. And this is classwork, which means that we are taking this up as a participation grade. Yeah. So don't sit there, pick your nose, and let everybody else do everything. But we're going to work this together because you don't know how to do it yet. Now, I want you to think back into the distant past of last week and recall our review day. Do you remember that day, or have you blocked it out with the other war memories?
I remember.
You remember. And do you remember the beautifully colored review cards? And there was a blue one. And number one, I told you not to do. Because it said to express something in terms of something else. And I was like, I haven't taught you how to do that yet. And so you didn't do it. Now you get to do it. Because I'm going to show you. Okay? So, looking at this fella, if I wanted to find x, the only other things in the picture here have y's. How could I find x? What kind of angle is it? It's an exterior angle. So how could I find the measure of angle x? I could add those remote interior angles. I could just add them up. What's the slight problem? I don't know how big it is. There is one here. We just don't know its measure. Okay, so how am I going to find the measure of this angle? It's supplementary with the linear pair here. And so I can go, all right, I can figure this guy out. How did I find that angle? find the supplement of an angle? I'm going to do 180 minus whatever's on the other side. So 180 minus the 100 minus y? I can do that. No, y. You said c. It's a y. Okay, so let's do this. What is 180 minus 100? 80. And what is it minus y? But yeah, if you minus a negative, you get a positive. So this angle down here is 180 plus y. Not 180, 80. My mouth didn't work. So 80 plus y is the size of this guy. Do I know how big that actually is? No, it's in terms of y. If I knew y, I could do it. Well, now that I have that, can I go back and find my exterior angle now? Yeah, because I know that to get x, I'm going to add up these two remote interior angles. So I'm going to add up 2y plus the 80 plus y. And then you can combine your like terms because you learned algebra, and x equals 3y plus 80. Is that as simple as it gets? No. What else could you simplify? I think that's as simple as it gets. Now, have I found x? Yes. It's in terms of y. So up here, x equals 3y plus 80. There's x in terms of y. Done and dusted. Right, that's it? Yeah. Well, no, that's it. You found x in terms of y. Shall we try another just to make sure it wasn't a mistake? So you come over here, and what are you supposed to find? M in terms of q. Okay. How will I find m? It's an exterior angle, so I need to add its remote interior angles. So I'm going to do m equals q plus, I don't have anything to add here. Oh dear, whatever shall we do? These are supplementary. How do you find that supplementary part? Subtract from 180. So 180 minus this 115 plus 2q will give me my interior angle I need. So you agree, what's 180 minus 115? 65. And minus a positive 2q? Just minus 2q? Okay. So now we found this interior angle. What am I doing with it? Yeah, these two guys get added together. So I've already got this q. Now I'm going to put it in the 65 minus 2q that I just found. And so m equals, is it q?
Negative.
You can do negative q plus the 65. Could you write it in the other order? Could you put it as 65 minus q? Yeah, that's fine as well. You can add and subtract in any order as long as the sign in front of it sticks. So the negative was in front here, the negative's in front here, you're good. It's a property we call commutative. You can rearrange your adding. Multiplication is the same way. Okay? Questions? Shall we make it harder? What do I do different on this one? What's different? Oh no! The exterior angle is not just z! It's 2z! So what am I going to do? Cry, and then thing. No, start off doing the same thing. This exterior angle, 2z, still equals the sum of my remote interior angles. It still works the same way. Okay? My exterior, I don't have one of the remote interiors conveniently. So how are you going to find this remote interior angle? Since it's supplementary, I'm going to do 180 minus the 160 plus v. So what do you get? 20. And it's minus v because this negative has to distribute. You have to subtract the 160 and subtract the v. Okay? So this interior angle is 20 minus v. So down here, I'm going to park my 20 minus v. And then you algebra, which I hope you... Stephen, what do you get when you algebra this guy?
2z is equal to 2v plus 20.
Wow. Have I expressed z in terms of v yet? No, I've expressed 2z. How do I get it down to just 1z? Divide everything by 2. Remember, if you do it to one side, you do it to the other. And so z equals, what's 2v divided by 2? V. What's 20 divided by 2? 10. So now I have z in terms of v. So z equals v plus 10. Okay? So go ahead and do the last one. I'll give you a minute to do that, and then we'll see how well you did. Did you already do it? Claire, did you already do it?
I did it.
You already did it?
Yeah.
Oh, let's see. We'll have everybody else do it, and then we'll see if you're right.
Alright, bet.
Oh, we've got a lowercase t. That's very helpful if it bends on the bottom. Okay, I'm done. Is that what y'all got? No.
Oh, yes.
W in terms of T. You keep wanting to bring the letter C in here, and it's not here yet. Okay? Now, the trick is remembering this a week from now when I haven't reminded you about it.
Right.
But that's going to come down to you knowing your relationships with your angles. Knowing that your exterior angles equal the sum of the remote interiors. And the remote interiors are supplementary to their linear pair. So you're going to have to just remember your geometry, because I know you remember your algebra. So what we're going to do now is I'm going to turn off the video. Y'all need to turn this in. Put your name on it. Either you tried everything or you didn't. So you get 100 or a 0. And then go turn it in and you can start your homework.
Not